Welcome. In this presentation we will see how wireless equipment can be controlled with CopperLan. Our demonstration is dealing with wireless microphone systems. In such systems, the audio is still received through UHF or VHF to avoid latency. Since we concentrate on the command and control aspects, we didn't implement any audio in our setup. The CopperLan control is done through Zigbee and wired Ethernet. In a commercial product, this comes in addition to the usual UHF, VHF audio transmission. Note that instead of using Zigbee, we could have used other variations of the IEEE 802.15.4 wireless transmission. This unit represents a typical microphone receiver. We have a button for pairing the receiver with the chosen microphone. There is a button for remote muting and a pair of increment-decrement buttons to control two parameters. In the middle we have the microphone. It has a single button which is used for the mute but also during the pairing stage. For the purpose of the demo, the display and LEDs show the parameters which are inside the microphone. As you see, all we have is a cable for the supply of the demo board, since the communication is all done through Zigbee. The last unit is the Zigbee station. It is the relay between receivers and microphones. We only have one of each unit here, but the system can encompass multiple receivers, microphones, and Zigbee stations. Let's see how it works. On the computer, we don't see any CopperLan equipment yet, besides the computer itself. You see MIDI on MacBook White. Okay, it's all the default MIDI ports that we have in the computer. I now connect the receiver supply, and so it appears on the network. As you could see, it's called RF module here, which is supposedly your RF receiver. I now connect the Zigbee station, which also will appear on the network. Now I will do the pairing. So I press the pairing request button on the receiver, and then instantly the same LED is flashing also on the microphone. I press the confirmation on the microphone, and automatically both become paired. As you could see, the pairing is confirmed by the blue LEDs, but also all the parameters are replicated between the two pieces of equipment. On the computer, we can see that the receiver has instantiated a sub-device, which is in fact telling that there is a microphone handled there. And it has established a link between the station and that microphone. We can now edit the values on the receiver. So if I change the value here, as you could see, they change also on the microphone, and same for the levels here, which are replicating on both sides. We can also monitor these changes on the computer. So I go into the editor, and I go into my microphone, and there, as you could see, if I change, let's say, the mute here, it is changing that muting LED also on the mic, on the receiver, everywhere, and I can change the values preset. Let's say I change like this, or I can change also the slider, and so the value is changing on the LEDs, as you could see, and the same works both ways. If I change on the receiver, you see the value changing here, or the setting there, or the mute. The editing is bidirectional. Changes I do on either side are replicated. Since all I have on the microphone is a mute button, you can see that this is changing on the receiver in the same way that I changed the other settings. This monitoring and editing can be done from any Mac, PC, iPad, or some dedicated CopperLan pieces of hardware. Now, let's say in case the microphone loses the contact with the Zigbee station, which I do by removing the supply. At that point, it may happen that I'm changing the settings separately on the receiver, which then will be not replicated on the microphone. As I reconnect the Zigbee station, the parameter will be replicated as soon as they have both find the identification pairing again. So the whole system is a turnkey solution ready to be implemented into commercial products. It is easy and low cost. In the microphone, we use the low-cost 8-bit microcontroller, as you could see here. And the CopperLan side is done with our usual CopperLan development board. Note that the whole CopperLan connectivity and application code could be implemented as a single chip solution. This demo focuses only on a tiny bit of what CopperLan can do. There is much more to say and much more to discover. Thank you.